It's deep in the past, and you're crouched by a fire with a raw piece of meat in your hand. You're hungry. And instead of just eating it, the way every other hungry animal on the planet does, you do something strange. You hold it over the flames and you wait. You let good food get hot and hiss and change color before you'll touch it. No lion does this. No wolf, no bear, no bird, just you. And that strange little habit may be the reason you have a brain big enough to wonder why you do it. Here's the thing. We tend to treat cooking like it's just something nice we do. Tastier food, softer food, a warm meal at the end of a cold day. But a growing group of scientists think it's much bigger than that. A researcher named Richard Wrangham put the idea in a book with a title that says it plainly. Cooking is part of what made us human. Not fire for warmth, not fire for safety, fire for the plate. And if he's right, then the question of when we started cooking is really the question of when we started becoming us. Start with the organ that makes us human, and here's where it gets interesting. The human brain is about 3 times the size of a chimpanzee's, and it is an incredibly expensive thing to run. Gram for gram, brain tissue burns energy far faster than muscle does, and it never rests. Even right now, sitting still, that lump of tissue in the skull is quietly eating a huge slice of everything the body takes in. A brain like ours is a luxury, and in nature, you don't get a luxury for free. It has to be paid for somewhere. So where did our ancestors find the money to pay for it? A pair of scientists, Leslie Aiello and Peter Wheeler, pointed at the gut. Compared with other animals our size, the human gut is surprisingly small, roughly 40% smaller than you would expect for a primate of our body weight. That, they argued, is the trade, because a long and hungry gut is an expensive organ to run too. Evolution shrank the gut and quietly spent the savings on the brain. We are, in a real sense, animals that traded stomach for skull. But wait, that should not work. A smaller gut pulls less energy out of food, not more, while a bigger brain demands more energy, not less. So you have a shrinking factory being asked to power a growing, greedy machine. On paper, that animal starves. Something had to make the food itself richer before it ever reached the gut, doing part of the digesting on the outside. That's exactly what cooking does. Heat starts breaking food down before it's ever swallowed, softening the tough fibers, unfolding the proteins, and bursting open the hard little packets of starch. Think of it as a first round of digestion that happens outside the body, over the fire, instead of entirely inside the gut. Wrangham's team actually tested this in the lab, feeding mice the very same food, some of it raw and some of it cooked. The mice eating cooked food pulled more usable energy out of it and gained more weight than the ones eating it raw. Same meat, same potato. More fuel in the animal just for having met the fire first. Cooking bought us something else too. It bought us time, and it changed the shape of our jaws. A chimpanzee spends a huge part of its day just chewing, hour after grinding hour, working its way through tough, raw plants. Even simpler tricks than fire turn out to help. In a careful experiment, researchers named Zink and Lieberman found that just slicing the meat and pounding the vegetables, with no fire involved at all, cut the chewing people needed by nearly a fifth. Add real cooking on top of that, and the mouth barely has to work. Soft food simply doesn't need big teeth and heavy jaws to get through it, so over time, ours got smaller. You might think, sure, but people eat raw food today and they're perfectly fine. Here's the uncomfortable part. When scientists surveyed people who had eaten a strict raw diet for years, they found something stark. On average, these people lost weight, often around 10 kilograms or more, and many of them became underweight. Among the women on the strictest versions of the diet, nearly a quarter stopped having their periods altogether. Their bodies simply could not pull enough energy out of raw food to keep everything running. A modern body, eating modern raw food, still cannot live on raw alone. So cooking looks less a nice habit and more a deal our whole body is built around. Which brings us to the real mystery. If cooking made us, then when did it start? And this is where it gets interesting, because there are rival ways to answer that. You can read the story in the ground, or you can read it in the body, and the two do not agree.
Read it in the body first.
Almost 2 million years ago, a new kind of ancestor shows up in the fossil record, a species we call Homo erectus. And this one looks oddly familiar. A bigger body, smaller teeth, a lighter, less brutal jaw, a brain noticeably larger than the ancestor that came just before it. Those are the marks of an animal that had suddenly started getting far more energy out of its food and no longer needed a giant grinding mouth just to survive. Richard Wrangham, the same scientist from the start of this story, looks at that body and says the answer is obvious. That is a creature that had already learned to cook. There's a problem, though. We can't find the fire. If our ancestors were cooking that long ago, there should be ancient fireplaces to dig up. But burnt wood and ash are fragile things. They blow away, they wash out, they rot. When we go looking that far back, the campfires simply aren't there. The oldest solid, widely agreed upon evidence of fire inside a shelter comes from a place called Wonderwerk Cave in South Africa, and it dates to only about 1 million years ago. That's already an enormous gap between the body and the ash, a long stretch of missing matches. And it gets stranger. Scattered early hints of fire are one thing. Fire as an everyday, every-night habit is another. By that stricter test, the campfires don't really become common until much later, only a few 100,000 years ago. Before that, our ancestors even pushed into cold northern lands without leaving much sign of regular fire at all. So the hard evidence says fire got normal late, yet the bodies had already changed far earlier. So who's right? Some scientists read the body. They say the smaller teeth, the bigger brain, the shrunken gut are cooking's fingerprints, pressed into our bones long before any campfire we can dig up. Others read the ground, and they say, show me the fire. No hearths, no proof. And honestly, this argument is not settled. It's among the liveliest open questions in the whole story of where we came from. But here's the quiet point that the fire reader has on his side. Of course the oldest campfires are missing. A single night's fire almost never survives across such a vast stretch of time. Bones and teeth do. So maybe the body really is the better record. Maybe your own small jaw and your own oversized brain are the clearest surviving proof that somewhere, deep in the dark, an ancestor held food over a flame and waited, long before any campfire we can still find. So the next time you stand over a stove or lean into a grill and smell dinner start to change, know what you're really doing. You're running the oldest trick our kind ever learned. The trick that may have fed the very brain that lets you stand there and think about it. We didn't just learn to cook our food. In a strange way, cooking is part of what cooked up us. So here's what I keep chewing on. If the fire really did build the brain, then every meal you've ever cooked is a tiny echo of the single most important thing our ancestors figured out. So I'll ask you, when do you think we first started cooking? Almost 2 million years back, where the bones point, or far more recently, where the ash sits? Tell me down in the comments.